Today we're going to start right triangle trigonometry, and it relies on the material we covered on Monday with the Pythagorean theorem, and yesterday with your degree measures and your radian measures. We won't get as far into the radian measures today, but we will as we move forward. So, with your right triangle trigonometry, everything relies on you operating off of a right triangle. So if I have this right triangle, A, B, C, where C is my right angle, then the sides that we work with, if I call the angle at angle A theta, then the sides I'm working with, I'm going to have the opposite side, the adjacent side, and the hypotenuse. And again, your hypotenuse will always be opposite your right angle and is always the longest side of your triangle. And so we can use trigonometric ratios in order to make relationships between the side lengths and the angle measures. So using angle A, you have probably been taught in the past the acronym SOHCAHTOA. And I write mine a little bit differently just so that it reminds me that I'm dealing with ratios. And so with your SOHCAHTOA, the way it works is my sine of theta, so in our case angle A, is going to be equal to the opposite side over the hypotenuse. My cosine of theta is going to be equal to my adjacent side over my hypotenuse. And the tangent of my angle theta is equal to my opposite side over my adjacent side. And what we use that for is to establish the different relationships between the side lengths and the angles so that we can solve for right triangles when we aren't given every piece of information. So with the Pythagorean theorem, you can only solve for a missing side length. And using the fact that the two acute angles of a right triangle are complementary, you can only solve for angle measures. But without the use of trig ratios, you can't solve for any other information. Another thing that you should call attention to is if I'm ever looking for the angle using the trigonometric ratios, then I'm always going to use the inverse of the trig function. So if I have theta and I'm looking for theta, then it's equal to the inverse sine of opposite over hypotenuse, or it's equal to the inverse cosine of adjacent over hypotenuse, or it's equal to the inverse tangent of opposite over adjacent. And you have all of these keys on your calculator. If you look at your calculator, then here you have sine, cosine, and tangent. And then directly above it in the blue, you have the inverse of sine, the inverse of cosine, the inverse of tangent. So you use sine, cosine, and tangent when we're looking for side lengths. You use the inverse of the trig functions when you're solving for the angle measure. The only thing you need to make sure is you need to check the mode of your calculator. Whenever you reset the calculator, it auto defaults to radians. So if you go into mode, you just want to make sure that your degree is always highlighted. Because if you're not operating in degree mode, then all of your answers are going to be thrown off because they're going to be given to you in radian mode. Okay, now, in addition to the sine, cosine, and tangent, we also have some inverse functions, and I'm going to go ahead and give you the reciprocal functions, but we won't actually work with them a whole lot until some future lessons down the road. But if our sine is opposite over hypotenuse, then the reciprocal of sine is the cosecant. So the cosecant of theta is equal to the reciprocal of sine. And this is hypotenuse over opposite. In a similar fashion, we have the cosine of theta being equal to the adjacent over the hypotenuse. Well, its reciprocal is the secant of theta. So the secant of theta is the reciprocal of cosine, and it's equal to the hypotenuse over the adjacent. And then the tangent of theta, being the opposite over the adjacent, has a reciprocal function, the cotangent of theta, and it's the reciprocal of tangent theta, and it is equal to the adjacent over the opposite. You may see some of these referenced in some of the practice problems that we're going to do today and on the homework. So just to keep everything straight, just in case you see them, this is what they are referencing and this is what they mean.